Everyone. So the day you have been waiting for has finally arrived. Today we get to talk logarithms again, um, which really we're not learning much new here. There's nothing here that I'm going to tell you that you didn't learn last year. But I think the second time around, it starts to sink in a little bit more and it starts to make a little more sense. Okay? So this shouldn't take super long, but we will just touch on kind of the basic of logarithms. We have a few more lessons on logs later in the chapter, so we'll firm some other things up then too. So let's first just start with notation, okay? Logs are really a rewritten version of an exponent. So when I write this down, y equals log base b of x, let's say. What we're really saying is this is the base of an exponential function. And this here is the exponent. In fact, the quicker you can wrap your head around the fact that really anytime you're finding a log of a number, you're really just finding an exponent, the more common sense logs will become, okay? So really what this thing is saying is if I take b and raise it to the power of y, it will give me x, okay? Now, I want to point something out that you may remember and you may not. But when we talked about exponential functions look like this. Y equals b to the power of x. So if you compare this to this, really you should see that the x's and y's have kind of flipped positions. And so what I would want you to take away from that is a log function and an exponential function are inverses of each other. Okay, logs and exponents are inverses of each other. They undo each other. Okay, so let's go back to this idea that when I'm finding the log of a number, I'm really just finding the exponent. So when I look at a question like this, log base 3 of 9, I'm going to do this kind of the long way and then we'll talk shortcuts. But what I'm really saying is log base 3 of 9 is equal to something. Okay? And then I'm going to use something called the circle method, which really I used back here, I just didn't draw it that way, is that this is really saying 3 to the power of x is equal to 9. So I could rewrite this thing as 3 to the power of x equals 9. And then it's just a matter of figuring out what x is. Now, we're going to have a way that we can actually solve for that. We're not going to get into that today. Today it should, for the most part, be mental math. You should be able to say 3 to what power equals 9 and know that x equals 2. So back here when we first started this problem and you saw log base 3 of 9, what I was really asking you there is what exponent do I need to turn a 3 into a 9? Okay? So same idea here. I'm asking what power turns a 6 into a 1 over 6? I'm asking you this question. 6 to what power makes 1 over 6? And so you may have to think about some of our exponent rules that we reviewed yesterday. What kind of exponent is it that turns a whole number into a fraction like that? That would be a negative exponent. And since my 6 didn't change from here to here, that must be a power of 1. So I would say this is x equals negative 1. Okay? Okay, this next one's got a couple of weird pieces to it. So first of all, square root of 32, that doesn't really get us anywhere, okay? So I'm going to rewrite this thing as 32 to the power of 1/2, okay? Because a power of 1/2 is the same thing as a square root. And when I'm talking logs, I want to be living in the land of exponents, okay? So again, if I had this thing equal to x over here and I kind of circled this around, what I'm really saying is 2 to what power is equal to 32 to the 1/2 power. Now that's still not quite as straightforward as the other ones were, okay? Here's what I'm going to do. I recognize that 32 is a power of 2, right? That I could rewrite 32 as 2 to some power. So I'm going to take this thing right here and rewrite it as a power of 2. I'm going to write this as 2 to the 5th power. Okay? And that's still being raised to the power of 1/2. So this is 2 to the 5th being raised to the 1/2. which I could then say is really just 2 to the power of 5 over 2. Okay, so what I'm seeing now is 2 to what power equals 2 to the power of 5 over 2. I'm saying these two things need to be equivalent. And that really just means that my x value here must be equal to 5 over 2. So this one was really more of a game of taking this thing and rewriting it in a form that was compatible with this one. I would say here, x is equal to 5 over 2. That was kind of a tricky one. Okay, we may need to practice those some more, but that's the general idea. We're going to see something similar in this next one. Log base 9 of 243. Okay, so again, if this were equal to x and I circled around, I would end up with 9 to what power makes 243? So here's the problem. Okay, we know 9 to the first, that's just 9. 9 to the second is 81. You might not know 9 to the third off the top of your head, but if you typed it into your calculator, you would find that 9 to the third is bigger than 243. Okay, so it's got to be somewhere in between 2 and 3. Okay, here's how we're going to come out and find it, other than the more formal way that we're going to solve for it later on. Okay, because again, we're going to get into the solving piece later. I'm going to go like this. I'm going to say I can write 9 as a power of 3. So I can write this as 3 squared. And then it also has a power of x on it. And I can write 243 as a power of 3. That's 3 to the 5th power. So what I have now, and let me just rewrite this off to the side. I'm going to go ahead and put the 2 and the x together. I have this. 3 to the power of 2x equals 3 to the power of 5. So I rewrote them so that they have the same base on the bottom, okay? Which is essentially what I did here too, is this had a base of 2, so I rewrote this one so it had a base of 2. This time I recognized that both of these were powers of 3, so I wrote this as 3 squared and I wrote this as 3 to the 5th, okay? Once I've got it in that form, I can say, well then, 2x must equal 5. Just like here, I said x must equal 5 over 2. Okay? This gives me a little mini equation to solve. 2x equals 5. And then when I solve for x, I also get x equals 5 over 2. Otherwise known as 2.5, correct? So if those of you who were thinking, oh, it's somewhere between 2 and 3, were automatically set on 2.5, you nailed that one. I do want to caution you that it's not always just halfway in between the two numbers. Okay, we have to kind of take it easy on you here because, again, we're asking you to do this kind of without a calculator. Okay, and by the way, these types of problems will show up on the no calculator part of your quiz next week. But if you're stumbling through these two here, particularly, we're going to practice these a whole lot more before then. Okay, so in this next section, I got a little bit ahead of myself here, and so I'm actually going to nix this next example because we're not at the point where we're solving these equations yet, other than just kind of doing mental math like we were doing up here. Okay, we're not at a point where we can solve this for x. We haven't done enough logs yet. You should probably be able to estimate it. Okay, you should probably be able to say it's between this number and this number, but we're going to hold on to that and come back to that later. All right, let's look at our example 2 here. Okay, so example 2, is a base 10. All right, and what we're going to do is we want to rewrite this thing in log form, and then I want to talk to you about a certain kind of log that I didn't mention before. So far we've been taking logs and rewriting them as exponents, but we can also take exponents and rewrite them as logs. And here's what that's going to look like. Log base 10, so this is where my base is, right? My base 10 here, of 73. And remember, it's always equal to your exponent. So this is how I would rewrite this thing in log form. Log base 10 of 73 equals y. Now, we can do this problem right now because of a special property of this thing, log base 10. Jot down for yourself. especially if you don't remember, that log base 10 is what's referred to as a common log. And in fact, because it's a common log, we don't typically even write the base in there. We just write no base at all. And if there's not a base written, we assume that it is a base 10. Okay, so log base 10 is what's called a common log. And common logs can be done with your calculator. The log button on your calculator does common logs for you. And that means this can go straight into our calculator. Now, not all logarithms can go straight into your calculator. On some of the newer calculators, they have some tricks that you can do it. But we're going to talk later how you can solve any logarithm. But for right now, all we're able to do is the base 10s. Let's see, glare on my calculator there. Sorry, probably making you dizzy. So I'm trying to do common log of 73. So on my calculator, I'm using the log button, which is way down here. Let's see if I can move this up for you a little bit. Okay, the log button, log 73. And notice on your calculator it doesn't show a base. That's because a common log is naturally or automatically base 10. So log 73, there we go. And so we would say it wants to the nearest hundredth. So I would say y equals 1.86. Okay. And I bet if I did 10 to the power of 1.86, it should come out awfully close to 73. Not as close as I would like it to be. I probably needed to hold on to more of that decimal there. Okay. But it said to the nearest hundredth, so that's my answer to the nearest hundredth. Okay. So example 3 is another one that I got a little ahead of myself. We don't really have a way to solve this yet because this isn't a nice happy power here. So I think we'll just skip that one. Okay, I was going to change it to something else, but we did one similar on the front page. But we can do this one, okay? Log of x equals 2.9, because remember when there's no base written here, we assume it's a base 10. Now, this isn't one we can type into our calculator because it's got an x there. I can't type in log of x on our calculator unless we're graphing or something. But I can rewrite this in exponential form, right? I can rewrite this as 10 to the power of 2.9 equals x. And then I can evaluate this part, 10 to the power of 2.9. Just to give you an idea estimation-wise here, I know this should be close to 1,000 because 10 to the third power would be 1,000, okay? But let's check it out. So I'm going to go 10 to the power of 2.9, and I get 794.3. Okay, and if I wanted to check, because this is a common log, I could do that on my calculator. I'm going to do common log of that previous answer, and I end up with 2.9. Okay, so that's how I could double check that one. So for today, really my goals for you are mainly the biggest thing would be questions like these ones here in example 1. Okay, and you're going to have some of these in your homework tonight. You'll have some more of these on Monday when we review for your quiz. Okay, and then just can you switch back and forth between log form and exponential form? Can you take a log and write it as an exponent? Can you take an exponent and write it as a log? Okay, those would be the 2 things you need to walk away with pretty solid on today. And we will practice and review all of this before we take your next quiz. Okay? Okay, homework for tonight is section 6.3 out of the textbook. Give it a shot. We will be going over that assignment and then reviewing on Monday, and your quiz is on Tuesday.